Hi everyone, we're going to solve these quadratic equations here by taking a square root. It may not always be obvious which ones will be square root, which ones will be factoring. You could actually factor these too. I'm just going to show it kind of both ways to show that there's options. We're always going to start with quadratics here is always try and get them equal to 0 if they're not equal to 0 first. These two are already equal to 0, the first two, so we're going to start with those so it'll be a little bit easier. Okay, to solve this, what we could do is try and figure out a GCF if that's easier. That's one option to start with, or we can try and just move things around. I'm going to show you the first option just to move this 8x squared over, and let's see what happens after that. So we get 200 equals 8x squared. Now we're going to try and solve this for x. So if you're thinking about how you would solve this for x, if that were just an x, not an x squared, you would divide both sides by 8. So that's what we're going to do here. We're going to divide these both by 8, and we're going to get 25 is x squared. So if you want to get x and you've got a squared, we do the opposite of the squared, which is a square root. And here's how we use a square root in order to solve a quadratic. The only thing I have to be very careful of is there's actually two options here. There's the positive square root and the negative square root. So when you do this square root, it's really two options. So x is the plus or minus square root of 25, which means there's two options, plus or minus 5. So that means x could be negative 5 or x could be positive 5. And now you could definitely factor this one too. Might be a little bit trickier to do just because it's kind of bigger numbers, but you can definitely do that. I'm just going to show the work off to the side here of how you would do it that way. So I like to have the x squared always be positive, so I'm going to move everything over. So the plus 8x squared and a minus 200 would equal 0. Then we could do a GCF, 8 times x squared minus 25 equal to 0. And then we could just factor the difference of perfect squares. X plus 5, x minus 5 equals 0. Then using what we call the zero product property, one of these things has to be 0. 8, though, can't be 0, so that's not going to be an option. But x plus 5 could be 0, or x minus 5 could be 0. And that's how we're going to get our two options for x that we already have. We already know the answers. X is negative 5, or it's positive 5. A little bit more steps there, so square root might be a little bit easier for these examples here, but you could do it either way. Factoring is obviously going to work whenever a quadratic is factorable. For a lot of these different methods to solve a quadratic, there's a fastest way and there's other ways that are obviously going to work as well. Here's one example of that. So I'm going to stick with the square root method just because it's a little bit quicker, and that's where this video is kind of focusing on anyways. So I'm going to add this 144 over. I'm going to get 4x squared equals 144. Then we're going to divide both sides by 4. We want to get x by itself, so we get x squared equals, looks like that's going to be 36. If we're ever not sure, we can do some long division here off to the side. So 4 goes into 14 how many times? Well, 4 times 3 would be 12, right? And then we just subtract. So 14 minus 12 would be 2. Bring down the 4, 24. 4 goes into 24, 6 times. Boom. And of course, there we go, no remainder. So x squared is 36. Take it x by itself, square root both sides, but don't forget there's really two options there. There's the plus or minus square root of 36, which means it's plus or minus 6, which you can write like that, or you can write it as negative 6 and 6 with a comma in between. So those are some quick examples there with square roots, a couple trickier ones down below. What I would always suggest for these is always get it equal to 0 first. No matter what you're doing for a quadratic equation, it usually is easier to get it equal to 0. That way you can see what your options are from there. I'm going to add these 10x's over. They actually cancel out, which is nice. We get negative 8x squared plus 392. Again, I don't love negative x squared terms, so I'm going to add that over just so I have everything positive. So 392 equals 8x squared. A little bit tricky division to do here. I know that 8 times 5 is 40. So 8 times 50 would be 400, but we're not quite at 400. We're 8 away, so it's probably 49. That would make sense, right? 8 times 49 would be 392. So that tells us that 49 equals x squared, which makes sense because we're looking for a square root next. So we do a square root, don't forget plus or minus, and we've got our answer. X is plus or minus 7. Negative 7 and positive, or positive 7. And over here, just a little bit crazier example, but same exact work really. Plus 6x squared to both sides. Again, I moved that one, not the negative 3x squared, because I want to avoid negatives. We're going to subtract 9x from both sides. That will get rid of it. And if max squareds are going to be on the right, let's bring the 239 to the right as well. So minus 239 on both sides. So that's gone. So 0 equals 3x squared. 9x's are gone. Minus 243. Okay, so we got to get, again, some big numbers here, but no big deal. Let's add the 243 back over. Now we got equal to 0. We can kind of move that over. So 243 equals 3x squared. I want to get x by itself. Divide by 3. So 24 divided by 3 would be 8, and 3 divided by 3 is 1. So there we go. 81 has to be x squared. And then to get x, we do our square root. Don't forget the plus or minus. And we've got our answer. X is plus or minus 9, which is negative 9 or positive 9. So the trick here for these square root problems, if you haven't noticed it yet, is that there's no b term. For each of these problems, there's an a and a c, but there's no b. When I say there's no b, I mean for ax squared plus bx plus c equal to 0. None of these have a linear term of bx. They've all got an x squared with a constant, which is why you can do this square root method. If you've got a b term, it's not going to be able to do this square root method because it's just not going to be able to solve that way. But if you do have an a and a c, then you can do the square root process, basically just getting the c to the other side, dividing by a and doing your plus or minus.